everyone. In this video, we'll be discussing about a question which is based on statistics. Let's have a look at the question. The following data gives the state-wise teacher-student ratio in higher secondary schools of India. Find the mode and mean of the data and interpret the two. Now we are given the number of students per teacher which are represented in the form of class intervals. And number of states or union territories represents the frequencies. We are required to find the mode as well as the mean of this data. So let's have a look at the solution. So let's have a look at the formula which will be used in this question. We will find the mean by direct method. And in the direct method, all we need to know about is FIs and XIs, where XI represents the class marks and FI represents the frequencies. And the formula for mean is given by summation of FI into XI divided by summation of FI. And the mode is given by the formula L plus F1 minus F0 divided by 2 into F1 minus F0 minus F2 into H, where L represents the lower limit of the model class, H represents the class size of the interval, F1 represents the frequency of the model class, F0 represents the frequency of the class preceding the model class, and F2 represents the frequency of the class succeeding the model class. Now let's find out the mean of the data first. First of all, we need to find the class mark of the given data in order to find out the mean. And the class mark is given by the formula upper limit plus lower limit divided by 2. Now in the question, we are given the number of students per teacher which are represented in the form of class intervals. And we are also given the frequencies which are represented as FI. Now for finding the class mark, that is XI, we need to add the upper limit and lower limit of the class intervals and divide them by 2. The class mark for the first class interval would be 15 plus 20 by 2, which gives us 35 by 2 is equals to 17.5. Similarly, for the next class interval, if we add the upper limit and lower limit and divide them by 2, we will get the class mark. So class mark for the second class interval is 20 plus 25 by 2, which is equals to 45 by 2, which gives us 22.5. So here 22.5 is the class mark for the second class interval. Similarly, for all the class intervals, if we add upper limits and lower limits and divide them by 2, we will get our class mark. Now our next step is to find the product of the class mark to their corresponding frequencies. Now for the first class interval, if we multiply 3 and 17.5, we will get 52.5. For the next class interval, if we multiply 8 and 22.5, we will get 180. Similarly, for all the class intervals, if we multiply the class marks to their corresponding frequencies, we will get FI into XI. Now if we add all these values, we will get summation of FI into XI as 1024. Similarly, if we add all the frequencies, we will get summation of frequencies as 35. So let's find out the mean now. And from the table, we obtain summation of FI as 35, summation of FI into XI as 1024. And we know that using the direct method, mean can be found out by using the formula summation of FI into XI divided by summation of FI. By putting the values, we will get our mean as 29.26. So mean teacher-student ratio is 29.26. Now let's find out the mode of the data. For finding the mode, first we need to determine the maximum frequency as well as the model class. Now you may observe that among all the frequencies, 10 is the maximum frequency. Hence, the maximum class frequency is equals to 10. And the class which is corresponding to the maximum class frequency is 30 to 35. So we can say that our model class is 30 to 35 because model class represents the class which is corresponding to the maximum class frequency, and our maximum class frequency is 10 in the case. So our model class is given by 30 to 35. Now we will find the values of L, H, F1, F2 and F0 in order to find out the mode of the data. Here L represents the lower limit of the model class. Our model class is 30 to 35, so lower limit would be 30. So L is equals to 30. Now H represents the class size of the interval. The class size of the interval is represented as the difference between the upper limit as well as the lower limit of the class interval. Now for the first class interval, if we subtract 15 from 20, we will get 5. In the second class interval, if we subtract 20 from 25, we will again get 5. For all the class intervals, if we find the difference between the upper limits and the lower limits, we will get our class size as 5. And the class size of the interval remains same for all the class intervals. So H is equals to 5. F1 represents the frequency of the model class. Our model class is 30 to 35. So our F1 is equals to 10. F0 represents the frequency of the class preceding the model class. Now our model class is 30 to 35 and the frequency of the class which is preceding the model class would be 9. So F0 is equals to 9. F2 represents the frequency of the class succeeding the model class. If our model class is 30 to 35, then our class succeeding the model class is 35 to 40. So the frequency of this class would be 3. So F2 is given by 3. Now let's find out the mode. And we know that the formula for mode is L plus F1 minus F0 divided by 2 into F1 minus F0 minus F2 into H. By putting all the values, we will get our mode. So our mode is given by 30.625. Hence, the model teacher-student ratio is 30.6 and mean teacher-student ratio is 29.26. So we can say that most states or union territories have a teacher-student ratio of 30.6 and on an average, the ratio is 29.26. Here, the average is represented as the mean. Now, in this lesson, we have learned that using the direct method, we can find the mean using the formula summation of fi into xi divided by summation of fi, and the mode can be found out by the formula L plus f1 minus f0 divided by 2 into f1 minus f0 minus f2 into h. Thank you so much for watching.